Welcome to week 2 of Math 121. An important skill this week to master is that of determining whether a function is odd, even, or neither. So let's look at this example. Here we have a rational function, and we want to know whether it's odd, even, or neither. Graphically, an odd function is symmetric about the origin. Graphically, an even function is symmetric about the y-axis. And of course, a function that is neither has neither symmetry about the origin or about the y-axis. So the idea is to plug in negative x and then simplify. So what you should think about in your mind is that you are plugging in an x and a negative x. So if you're imagining a graph, you're imagining your x perhaps over here on the positive side and your negative x over here on the left side. And the idea is that for the function to be even, the y value at x and at negative x will be the same. So that's what an even function is. An even function is if you go the same distance to the right and to the left, you'll go up or down the same. The y value for x and negative x are equal. Similarly, if we plug in negative x and we simplify what we get, and we end up with the opposite of the original function, that's negative f of x, what that means is that x and negative x have y values that are opposite. So if the y value is up at x, it's down at negative x. And this is what we mean by an odd function. So our whole goal is to determine what happens at negative x to check out symmetry here. So first we plug in negative x for all of the x's over here. So we'll drop in a negative x for every x, keep parentheses there so that we can then do our simplification. So when we go to simplify, negative x quantity squared. Well, the power is even there, so the negative in front will actually disappear. Negative x times negative x is positive x squared. No change with that negative 4 there. Now down below, the power is odd. Well, when the power is odd, the negative is preserved because negative x times negative x times negative x, there's 3 negatives being multiplied together there, so that will leave us with negative x cubed. Now let's pull that negative out of the denominator, and that negative can actually be pulled right out to the front of this rational function, so we end up with this expression. And when we compare that to the original function, we see that we have negative 1 out here in front times the original function. So in other words, we're ending up with negative 1 times the original function. So our conclusion here is that the function is odd. So again, this can be observed graphically if you open Desmos or GeoGebra and graph the function that we have here, the rational function. You'll see that the symmetry is about the origin. Hope this helps.